Tannins are plant substances belonging to the polyphenol group of substances. Their common feature, which distinguishes them from other polyphenols, is the ability to bond with proteins and other biological macromolecules. The biological effects of tannins are associated with this ability to form complexes. Interactions can be reversible or irreversible. The type of reaction depends on the structure of tannin and the physiological conditions in which it takes place. Irreversible interactions cause the tanning effect, forming covalent bonds between proteins and tannins. The tanning effect is traditionally and in modern production exploited by the leather industry, where tannins are used to turn animal skin into leather. The astringent therapeutic effect is due to reversible reactions such as hydrophobic interactions and hydrogen bonds. The astringent effect is used to relieve inflammation of the oral cavity, against diarrhea and in hemorrhoids. On the skin, we achieve an anti-inflammatory effect and prevent sweating with the help of tannins. Tannins are very different in chemical structure. For this reason, they are divided into two large groups: hydrolyzable tannins, which include galotannins and allagotannins, and non-hydrolyzable or condensed tannins, which include catechin tannins. But there are also mixed tannins, for example, galocatechins, which are also hydrolyzable. Hydrolyzable tannins are less persistent in the presence of water, that is, in wet herbal drugs, especially in basic and acidic pH. Non-hydrolyzable tannins are more stable in the presence of water and react with oxygen. Since tannins are important for the therapeutic effect of many herbal drugs, determining their content is also prescribed by the pharmacopoeia. The analytical procedure is described in section 2.8.14, Tannins in Herbal Drugs. Details of the procedure, such as the weight of the herbal drug used, differ from one drug to another and are therefore given in the monographs of each herbal drug. We will determine the tannins content of the herbal drug by first extracting tannins with hot water. Other hot water-soluble substances such as non-tannin phenols and non-phenolic substances will also be extracted. The sample will then be divided into two parts. In one part of the sample, we will directly measure the content of total phenolic substances, that is, the sum of the tannin and non-tannin phenol content. The measurement will be carried out by measuring absorbance after adding phosphomolybdenum reagent that reacts with all phenols to produce a blue complex. Skin powder will be added to the second part of the sample. This is dried animal skin ground into powder. The skin powder will bind tannins, which will be removed along with the skin powder when filtered. Using the same reagent as for the first sample, we will measure the content of the phenols that did not bind to the skin powder, that is, non-tannin phenols. The tannin phenol content will then be calculated as the difference between the two measurements. We will use a phosphomolybdotungsten reagent, also referred to as Folin-Chocotot reagent or industrial FC reagent. If we would prepare it ourselves, the process would be: dissolve 100 g of sodium tungstenate and 25 g sodium molybdate in 700 ml of water R. Add 100 ml of hydrochloric acid and 50 ml of phosphoric acid. The mixture is heated to boiling under reflux for 10 hours. Add 150 g of lithium sulfate, 50 ml of water and few drops of bromine. Boil to remove excess bromine. Cool, fill it up to 1000 ml water and filter. The reagent must be yellow. If it's colored greenish, boil it with a few drops of bromine. Add 1 ml phosphomolybdotungsten reagent. Add 10 ml of water. Fill with saturated sodium carbonate solution up to 25 ml. Wait 30 minutes. Measure the absorbance at wavelength of 760 nanometers. The blank sample is water. The absorbance measured for the solution that has not been treated with skin powder is referred to as A1, and the one treated with skin powder is referred to as A2. The absorbance of the standard solution is referred to as A3. The tannins content of the drug expressed as a percentage, grams of pyrogalol equivalents per 100 grams of drug, is denoted by the letter C and calculated using the formula shown. The difference between A1 and A2 represents the absorbance of tannins. When dividing by A3, we calculate the factor by which the concentration of tannins differs from the concentration of the standard solution. This is multiplied by the quotient, which represents the concentration of the standard solution. Mass of the standard solution divided by the volume of the standard solution and the dilution factor. In this way, the concentration of tannins in the diluted extract, which went into colorimetric reaction, is obtained. This concentration is then multiplied by the volume of the extract and the dilution factor to obtain the mass of tannins in weighted herbal drug. This mass is finally divided by the weight of the drug and multiplied by 100 to obtain the tannins content as a percentage. The result of the analysis is compared with the prescribed result in the pharmacopoeia. We found that oak bark contains more than 3% tannins, meaning it is of adequate pharmacopoeial quality.